How do we write the corresponding sine equation again? I'm going to remind you that we had this thing that said that, I'll write it down for you. It says that the cosine plus the period divided by 4 gives you a sine equation. So right now, the phase shift that we have is x minus 2. Right? That's the current phase shift. But we're going to add to that a quarter of the period. The period, remember, I'm going to take you back. The period of the function was x equals, was 10. So I'm going to go ahead and say, okay, 10 divided by 4 is 2.5. So I'm going to take my x minus 2, and I'm going to add on this 2.5. So that, of course, should give us that this should be x plus 0.5, 0.25 that is, minus 2 plus 2.5. Hopefully everybody makes sense. Hopefully that makes sense to everybody. So here comes my sine equation now, right? So my sine equation is y is equal to 4.5 sine. It's the same pi over 5. We know it's x plus 0.25. And then plus 7 point, oh geez, I didn't give myself enough room to do that. Do that all the time. Let's see if I can bring the whole thing over. Plus 7.5. Okay, wouldn't it be 0.5? Didn't I put 0.5? Oh, why did I put 0.25? Oh, thank you. Thank you very much. Yes, I just saw everybody is desperately trying to save me from myself here. So let me fix that. Let me fix that. Yeah. Yes, you have a right to let me know that I got something wrong. Absolutely. 0.5, not 5, but 0.5. If we had graphed it, we certainly would have figured out that there was something wrong. Also, are we using decimals because of the A and the C are decimals? That's fine, Noah. I'm okay with that, right? You're thinking maybe you wanted to put, what, 9 over 2 and 15 over 2? That's fine. I mean, if it's a decimal where it terminates like that, then it means you're not even rounding it. So I'm okay with that. I'm fine with that. All right. Okay, and thank you for pointing that out to me. That was important that we got that right. Okay, let's answer some more questions now. So we've got the sine and the cosine values, our equations. Predict a value for when x is equal to 25. Right? When x is equal to 25. So now, if you look at the table of values, there is no 25 in the table, right? The table stops at 15. So how do we know what the value is likely to be when x is 25? Well, what do you think, folks? What do we do to figure out what the corresponding x value would be, corresponding y value, sorry, when x is 25? Yes, Jeremy, go ahead. No, it is a substitution. That's exactly what we're expected to do. So what I'm going to do is, go ahead. Because it's the same thing. Predictions are usually based on models, and our model is this equation right now. So if I wanted to make a prediction, I would use a model to do that. That's precisely how models are used. Are we supposed to estimate? Well, you know, it says predict a value for x equals 25. You could say that you're estimating, but I think that we have a more accurate tool for doing that, and that's called this equation. So what I'm going to do is I'm going to use the equation when x is 25. So y equals, and you're going to grab your calculators right now and help me out with this, sine of, I'm going to use the sine version of it. Doesn't really matter. We could use either one. So pi over 5, 25 plus 0.5 plus 7.5. Okay, so I need one of you. Are we supposed to estimate? Because minus 6.1. You're getting 6.1. Is that everybody getting the same value? 6.1? Yes? I mean, I need you to all be doing this for yourself now. Okay, Emily says, yes, she got that. Okay, great. So 6.1 sounds about right. Now, there's another way that we could have got that value without actually using the equation. I want you to notice where 25 is in the scheme of things. This thing has, I mean, you don't have to go through this whole process to do it, but this thing has a period of 10, right? So if you think back, taking 25 as the number that you want to work with, go 10 back from that, right? That should give you the same value. 10 from 25 gives us 15, which is also 16.1. Go 10 back from 15, which takes us to 5, gives you 6.1 again. So every time you go 10 along the x-axis, you get the same y value. So since 25 is 10 away from 15, I should get the same value as 15. So rather than calculating it, I could have done that as well. Okay, so hopefully that makes sense, everybody. 6.1 sounds absolutely correct as a prediction for when x is equal to 25. Next thing is predict the first positive value when y is equal to 10 and round to the nearest 10th. Any thoughts on how we could do that? So we don't have any 10 in this table, right? We have the graph going from 8.9 to 11.1. I would think 10 is probably going to be somewhere in between those two, right? Then it goes to 12, then it goes to 11.1. Then so there are various places where 10 would make sense. So for instance, all you do is follow the pattern of the fives for the fives. For the fives, when you say the fives, I'm just trying to see what you're saying here now. Because when you say fives, you're talking like 10, 5, 10, 15, 20. That's what you're talking about there, Jeremiah? Yeah? Okay. Okay. You're talking about are you talking about the question before the one for 25, or are you talking about part 3 of the question? What part are we talking about here? Question 2, yeah, but for 25 though, I would go up in tens. I wouldn't go up in fives. Because if you went up in fives, then you would say, okay, that means that I could use maybe when the value was 10, for instance, or when the value was, values like those, I'd say go up in tens rather than in fives, because the period of the function is 10. That's why I'm using that as the way to get other values that are multiples of 10. Okay. All right, let's get to the last part of this question. Predict the first positive value for when y is equal to 10. How would I solve that? And then we said the first positive value, because there are different times when the graph is going to be equal to 10, or the y values are going to be equal to 10. I'm seeing one of them as between 8.9 and 11.1. Well, all I did was see the value alternate between 6 and then just extrapolate. But I'll do it by the period then. Yeah, I think by the period it would be probably the best way to do it. Okay, going up in tens, since you know that it repeats every 10 values on the x-axis. I think that's the more accurate way to do it. But anyway, let's get back to part 3 of the question. So the question is the first positive value. Now there are lots of places where this graph is going to be at 10. I'm saying somewhere between 8.9 and 11.1. Somewhere between 11.1 and 8.9. All of these places, but they want the very first time it happens. So I'm trying to think, it must be somewhere between 0 and 1, right? That must be where it first hit the 10, according to what it's asking for, the very first positive value for when x is equal to 10. Okay, so let's see if we can come up with an answer for that, right? What do we do to answer that question? Can anybody give me some direction on that? I want the y value to be equal to 10, not the x value, right? We've already done one where the x was 25, just plugging that in and good. Sub 10 in for y, absolutely. So we'll do exactly that. So what I'm going to do is, let me copy this equation over onto the other page. Let me see if I can do that. Okay, so let's copy that, because I don't want to use up. Actually, let me go back. Let me add a page, and then we'll paste this in. So there's our function. And Harish, you're right. Let's sub in 10 for y. So 10 is equal to 4.5 cosine pi over 5 x minus 2 plus 7.5. Okay, what happens next? You're right. What happens next? All right, how do we solve for x? Because that's what we're trying to do. How do we solve for x? What are the steps involved in solving for x? What's next? Excuse me. Move the 7.5 to the left. Okay, we can do that. So that would be 7.5 taken away from 10, which is be 2.5. 2.5 is equal to 4.5 cosine pi over 5 x minus 2. Okay, so I've done that. All right, so Joel and Jeremy are both right. What happens next? We're trying to get that x, trying to solve for that x. What's my next step? Divide both sides by 4.5. Okay, we can do that. So 2.5 divided by 4.5 is equal to the cosine of pi over 5 x minus 2. Okay, that sounds okay. We've done that, Jeremy, Joel, Harish. You've all set me off on the right path. Oh, what happens next? And by the way, I don't want to hear just the same people all the time. I need to hear some new voices here, right? What happens next? We still haven't solved for x. So give me some ideas as to how I can get that x on its own, because that's our goal. So 2.5 over 4.5 is equal to the cosine of that stuff inside the bracket. All right. Go on. Do I need to call on somebody in particular here? Because we've done this kind of thing before. I want to get that x on its own. Move cosine to the other side. Tell me how we do that, Elizabeth. Tell me how. I want to know how exactly that's done. Inverse. Okay. Okay. So what we need to do is find the inverse, the cos inverse of the 2.5 over 4.5. Right? Okay. So let's do that. Arc cosine. Okay. Wow. You're using those fancy terms there, Joel. So that means that the thing that I'm taking the cosine of, so this thing right here that I'm pointing to, that thing, that pi over 5, x minus 2, that's equal to cosine to the minus 1 of 2.5 over 4.5. Okay? Aliza, please go ahead. Aliza, go ahead, please. You had your hand up. Was that on purpose or was that by accident? I'm recognizing Aliza. Her hand just went up a few minutes ago and I don't hear anything now. Okay, so I'm going to go ahead since that might have been a false alarm. Okay, so that's what we need to do. Cosine to the minus 1 of that, right? Well, that's okay. So let's go ahead and get that on our calculators now. Go ahead and get that on your calculator. What's the cosine to the minus 1 of 2.5 over 4.5? And of course, we need to figure out what quadrants they go in and all that good stuff. All right. So go ahead for me now, please. So this stuff over here, the pi over 5, x minus 2, is going to be equal to whatever this number is. And we can call this prime for now, by the way, because we don't know what quadrants they're going to be in and all that good stuff yet. I need your help, folks. Get the calculators out. You think you get it. You think you got it. Okay. And I'm hearing from various people 0.98. Looks like 0.982. All right. Thank you, Elizabeth, and everybody else. Okay. Let me thank you all. 0.982, Travis, Elizabeth, Karis, Harish, Emily, Jeremy, Joel. Yeah. Okay. What happens next? Approximately, by the way. Approximately. Yes, Jeremy. Or another way of looking at it, and by the way, before we do that, let's just figure out where this angle is. What quadrant should this angle be in? What quadrants? Because there's more than one. It was a positive cosine before. where do we find this angle? This is important for us to look at. Where do we find this angle? What quadrants make sense to you for us to find this angle? Anybody? Quadrants what? Which quadrants? We need a positive for cosine. Think of the cast rule. Right? What quadrant should I put this angle into? Oh, sorry, I just realized that a bunch of you put the answers in. I was way up in the chat, 1 and 4. Okay, so I'm going to go ahead and put those in. One of them is here, one of them is here. Both of these are 0.982. 0.982, 0.982. Okay, so Jeremy just said divide by pi over 5. I'm going to say multiply by 5 over pi. Because that essentially is the same thing. Multiplying by the reciprocal has the same effect. So x minus 2, oh, by the way, so these two angles are the two angles that we're going to be focusing on. Let's focus on the first one, 0.982. So x minus 2 is equal to 0.982 times 5 over pi. Let's test that out. Remember, there are several answers for this, and we're trying to find the very first answer, right? The very first answer. Okay, so can I ask you to do that for me, please? What is that approximately equal to? 0.982 times 5 over pi. I'm looking to the chat to see who is going to give me that answer. 0.982 times 5 divided by pi. So 4.91 over pi. Oh, I see what you're getting. But just give me the answer. Give me the actual number, please, Joel. So I'm getting 1.5. I'm getting a different answer here. 1.563. Okay, that sounds like what a lot of you are getting. And then I'm going to add 2 to that. 1.563 plus 2. It's giving me what? 3.563 approximately. Now, that answer may be right, but it doesn't look like the answer I'm looking for, though. Can we take you back to the table for a second here? That answer, in fact, let me look at that answer again. That answer of 3.563, right, is somewhere between here and here, where I'm pointing to right. In fact, let me erase this stuff here. That answer is somewhere between 3 and 4. And yes, we can confirm that 10 on the y-axis is somewhere between 11.1 and 8.9. But that's not where we should be looking for our answer. Our answer is supposed to be the very first positive value for when y is equal to 10. So I'm thinking that answer should be somewhere between here and here. Right? Instead of going from 11.1 to 8.9, yeah, we're going to get 10 somewhere in there, right? There's going to be a value of 10 on the y-axis somewhere in there. But what about when we're going from 8.9 to 11.1? Should we have crossed over the 10 at some point there on the y? And therefore, we should get an answer between 0 and 1 on the x. How are we going to get that from this calculation? Can anybody see how we might be able to get that? Right? We used the angle of 0.982, didn't work, right? We got an answer which is right, but not right for our situation. So how do we fix this? Okay, Jeremy, you have an idea. (0.982) is fine, but it's not giving us the number that we want because let me take you back to the table, right? That's an answer that is between 3 and 4, right? The final answer for x works out to be, I'll show you again, 3.563. Now, would you agree with me, Jeremy, that 3.563 is somewhere between the 3 and the 4 on the x-axis, which, yes, would give us 10 on the y, somewhere between 11.1 and 8.9. As you go down from 11.1 to 8.9, it's going to cross there somewhere. No, he's saying 0.982 for x. No, Jeremy, I disagree with that completely. Completely disagree with that. Because this thing says that pi over 5 times x minus 2 is what is the 0.982. If that's what you're saying, Jeremy, I can't agree with that at all. That's not my value of x, right? Because x is buried inside of this thing. When we wanted to get rid of the cosine, we took the thing that cosine was being taken for, which is this thing, and set it equal to cosine to the minus 1 of the other side. That's the way we do it. But the x is still buried inside of this function. We had to multiply by the 5 over pi, and then we had to add the 2 and all that good stuff. So I'm thinking that's not the answer we want. That's not the answer we want. So this answer in the first quadrant is not helping us out. Is there somewhere else we can go that might help us out? That's the question I'm asking the class now. Because that didn't work. It's basically the problem. It didn't work, right? Not that it's a wrong answer. It's a wrong answer for what we were being asked. That answer of 3.563 works where I'm pointing to right now. It's between the 3 and the 4, and there is a y value of 10, so between 11.1 and 8.9. So it's a valid answer, but look at what this says. We take the first positive value for when y is 10. So the answer we're looking for should be somewhere between 0 and 1, right? Because somewhere between 0 and 1, y goes from 8.9 to 11.1. Use a sign graph. I mean, a fraction, Noah says. Use the sign graph. Interesting idea. Let me take you back to this graph a second. I wouldn't say it's a sign graph. You're saying go to the graph and you use a graph, is what you're saying. Yeah, because we did have a graph for this already from yesterday, I remember. But we need to find another strategy. All right. So that 0.982, you agreed with me, was either quadrant 1 or quadrant 4. Can we all agree on that, first of all? Quadrant 1 or quadrant 4? Can we agree on that? We can. Okay. So my question is, should I, grab my stylus here again, should I make, since this first angle here didn't work, should I try to get to this one over here? Should I try to go all the way over to this one here in the fourth quadrant and use that one? You think that's going to be better? What do you think, folks? Is that a better angle for us to use? In other words, 2 pi minus 0.982. What do you think? Is that a good one for us to go with? No answer. Should I use a bigger angle? Ava and Elizabeth and Jeremiah say yes. Well, if I use a bigger angle, so bigger than 0.982, what's going to happen to this value of x at the end? Is that going to be an answer closer to the one we want? Because remember, we want an answer which is smaller, okay? So it's going to go up. We're probably going to get the answer. You know what we're going to get? We're going to get an answer between here and here. When you go from 8.9 to 11.1, that's what we're going to get. So that's not going to help us out too much. Is there another way that we can possibly get an answer? Can anybody think of another way we could get an answer? Well, let me ask you this. There are two positions that we can get an answer that work for cosine. One is in quadrant 1 and one is in quadrant 4. We went in a positive, so here's my clue for you now. We went in a positive rotation, and we first of all found this angle here to be 0.982. It was too big. If we continue going in a positive rotation, that's my clue. Jeremy thinks, what if we went in a clockwise rotation then? What if we went this way instead? Right? Because the whole thing is we need to be 0.982 away from the x-axis in quadrant 1 and quadrant 4. That's where we need to be, right? Those are the two positions that will give us this cosine to the minus 1 of 2.5 over 4.5, either in quadrant 1, when it's positive, by the way, either quadrant 1 or quadrant 4. but we don't have to get to them by necessarily going in a positive direction, which is counterclockwise. We can get to them by going in a negative direction. So what if I were to go this way to get the fourth quadrant angle? What angle would that be going in a negative direction? Can you help me out with that, please? If I were going this way instead, right? Okay, do you see the answer that Jeremy just put into the chat? Negative 0.982. Do you see that? How about we try that one? Right? That's still taking us into the fourth quadrant. We're just going at it in a negative direction. Right? The important thing is to get to the two places that we want to get to. One is in the first quadrant, one is in the fourth quadrant. If we took 0.982, that still takes us to the fourth quadrant, just that we're going in the opposite direction, which means that we're going in a negative direction. So here's what we're going to do. This answer isn't wrong, it's just not right for us. Okay? So here's what I'm going to do. I'm going to do the same calculation again and say pi over 5 x minus 2 is equal to minus 0.982. We're going to go through all the stuff we just did using this instead. So it's going to be x minus 2 is equal to negative 0.982 times 5 over pi. All of these are approximate answers. And therefore, x is equal to negative 0.982 times 5 over pi plus 2. Do we need to write the positive version first if we know it would be wrong? My thing is you try it, right? It may have worked. If we were using the signed version of the equation, it may have worked. In fact, we'll try that out in a minute. Let's see if the signed version would have given us that, because the signed version is going into quadrants 1 and 2. So maybe the signed version would have worked, but we'll try that in a minute. I want you to get an answer for me now, though, with this minus 0.982 times 5 over pi plus 2, and tell us what you're getting from that. Again, approximately equal to. And we're crossing our fingers and hoping that this time our answer will be somewhere between 0 and 1. And I see what Joel has, and I see what Jeremy has, and I see that Noah is agreeing 0.437. Right? Now, how does that square with what we're doing before? That kind of works really well. Somewhere between 0 and 1 works really well. That should give us, in fact, if you want to test that out, excuse me, what you could do is, if you go back to this equation we had in the first place, put in that value of x. So it's not going to be exactly 10, by the way. It's going to be pretty close. Into either of the equations, either the sine equation or the cosine equation. Test that out for yourself right now. 4.5 cosine pi over 5 times 0.437 minus 2 plus 7.5. Try that out for yourself right now. Your answer should be, it's not going to be exactly 10. It's probably going to be like 9 point something or 10.0 something. It's going to be close, but not exactly equal to 10. Could you try that for yourselves, please? You all have calculators there, right? Put it into the original equation. That answer that we just got of 0.437, the one that's in the chat right now. And tell me how close you come when you put it into your calculator. So 4.5 cosine pi over 5, use the value of x, 0.437 minus 2, close your bracket twice, plus 7.5. Tell me what you're getting when you do that. It's going to be an answer that's either a little bit over 10 or a little bit under 10, or should be anyway, if we've done this right. Okay, so I'm looking to see what people are getting. Look at that. Noah's saying 9.998. Did other people get that when they did this? Carrie says yes. Okay, Elizabeth says yes. Excellent. Jeremy says yes. No, look at that. He's even closer, 9.999. So there you go, right? Does that? And by the way, just so you know, our first answer, let me go back to our first answer. Our first answer that we got, where's our first answer? A 3.563. That's also going to give you 10. Don't get me wrong. If you put this answer into the calculator, you're going to get 10 as well. But the question is, where's the first one, right? So if you have to go back and maybe rotate in a negative direction to get it, sometimes that's the way to do it. Now, you asked, somebody was asking about I forget what the question was, but I said we could use a sine function and see if the sine function would have given us a better answer. Well, let's try to see what happens with the sine function. The sine function is quadrants 1 and 2 for this, right? So let's go and try that right now. So let me go and copy the equation as a sine equation, which was x plus 0.5. Oh, sorry, go back. Brand new page. We don't have to do this, but I'm just showing you that, the sine function could also work as well. I'm going to erase the cosine part and put in sine, and then erase the minus 2 and put in plus 0.5. So I want to go through the same process again, just to show you that whether we use sine or cosine, we should get the same answer. Do we have to go in a negative direction for this? We may. Let's see what happens. Let's see what happens. So let's take the 7.5 from, so first of all, set it equal to 10. So 10, 4.5 sine pi over 5 x plus 0.5 plus 7.5. Okay, same process. Take away the 7.5 from the two sides. That would give me quick call pass. Okay, Jeremy, back within 5 minutes, please. That would give me what, 2.5 again over 4.5. So that's equal to the sine of x plus 0.5. Right? And then we're going to take sine to the minus 1 again. So this thing, the pi over 5, x plus 0.5 is equal to sine to the minus 1 of 2.5 over 4.5. Okay? Can somebody tell me what this works out to be, please? Quickly. What does that work out to be? What's the sine to the minus 1 of 2.5 over 4.5? What does that work out to be? If you could do, the quicker you could do that for me, the better. So we can move on to the other question we have to do, and then I'll give you some time to get your homework done. Okay, so 0.589. Thank you very much. 0.589. So pi over 5 x plus 0.5 is equal to that. So we're going to do exactly the same thing. We're going to take x plus 0.5, I don't need the brackets anymore, is equal to 0.589 times 5 over pi. So go ahead and do that. And then let's do this. So x is going to be equal to the 0.5, 0.589 times 5 over pi, but minus 0.5 this time. So go ahead and tell me what that is. Thank you, Jeremy. Go ahead and tell me what that is, right? So 0.589 times 5 over pi minus 0.5. Now remember, we did this for the first quadrant. Remember, for this one, right, sine is positive in quadrants 1 and 2. So this angle that we're looking for of 0.589 could be in either quadrant 1 or in quadrant 2. So what are we getting? Look at that, 0.437. So in other words, we got it from using the first quadrant angle on this one. We didn't have to go in a negative direction. So Jeremy, to answer your question, you asked us before at 0.43. Same answer, by the way, as what we got before. To answer your question, if you can see what Kayla, Jordan, Emily, and Nicholas have in the answer, and Keontae all have in the answer sheet, we got this answer by using the first quadrant angle for sine. Do you see what we're saying here, Jeremy? So don't always assume that you have to go to the second one, right? Sine and cosine will both give you the same answer, but whether you have to go into, a negative rotation or go to the second quadrant or something, no, it just depends. Just depends on how it works out. It will still give you the same answer. And I did suggest that we use the sine function. Just yeah, is sine always the best way to go? I don't know, right? But as long as you understand, Noah, and everybody else, that if the answer that you're getting isn't the one you want, there's a way for you to get, either a lower answer or a higher answer. In this case, we wanted a lower answer than the one we got. So we decided to go in a negative rotation to get that. And that's sometimes how that works. Okay, moving on. We got to move on. This table is our next table that I want you to work on for me right now. I need all of you to, using these values, different from the values that we had before, figure out the equation for sine and cosine. Once you figure that out, I'm going to show you how you can create a link from Desmos so that you can give me your homework tonight by just giving me the link. The link is all we need. Okay? So I'm going to leave that down there, and I can make this bigger. I'm going to mute my mic. There you go. That's big enough, I think, for everybody to see. I don't want to necessarily give you any hints at all. If you need a hint, please let me know. But I want you to take these values, put them in Desmos. So create a tab with Desmos in it. Start thinking of the equations and see if you can match those two up, please. Okay? See if you can match those two up. So, and then you're going to create a sine and a cosine equation. And we're going to try again to get the first x value for when y is equal to 5 and round to the nearest 10th. Similar question, different table. Let's see how you do with that. Okay? So, do we need to go through some stuff as a class to help you out, or is everybody reasonably comfortable with putting the, first of all, the graph together, the scatter plot, and then also come to an equation? What's the A? What's the C? What is the period? And therefore, what's the K? And what is the vertical, the phase shift? Does everybody feel reasonably comfortable doing this on their own, or does anybody need a push start with that? Let me know, folks, because I'm going to be asking one of you in a second to give us the benefit of your graph.